So the heapify itself, well, it just has to know the array, okay? And I'm going to go down here into the function itself, and we'll now start by determine the position of the last, that is going to be the lowest, right? So that is the lowest parent node. Lowest parent node. Okay, well, what is that going to be? There's another simple equation for this. Start is equal to n. So, well, we're going to define n down here within the heap sort. So I'm just going to then put this into this function here so we don't have to define it once more. Okay, so n minus 1, and we're going to divide that by 2. And then the n is going to be n minus 1. Okay, so this is the position of the last, that is the lowest parent node. Well, how does that equation work? N minus 1 divided by 2. So let's go back up here. If we look at this tree here, it has 1, 2, 3, 4, 5 elements, obviously. And now we're going to compute n minus 1. So 5 minus 1 is 4. We divide that by 2. So at index position 2, there should be the last. This is the lowest parent node. And if we look at this 0, 1, 2, it now says that 3 is the lowest parent node, okay? And the second, it's not the lowest. So if you look at this, 2 is also a parent node. It has some actual children. And 3 it's sort of the last element on the second to last layer. It's kind of weird to talk about 3 as the actual parent because, I mean, it doesn't really have any children. It could have. It's just on the layer of that penultimate layer of the tree, okay? So you might change this to not parent node, but, you know, the last element of the second youngest generation or something like that. It doesn't really matter, okay? Anyway, once we've determined that and the end is n minus 1, we'll now call the sift down function. So call sift down for all parent nodes, working yourself, ourselves up the tree. Okay? And so while start is greater or equal to 0, remember start will now be updated. And we're going to yield from, this is important because we're not returning from that function. Remember, with this whole generator idea, there's no return except this, and here the function just terminates. So we're now yielding from instead of getting the return statement from that, okay? Start and end, so this is these two things. And yeah, actually, we now have to worry about this. No, we don't, because yeah, we're just pasting start and end into this function. We took care of that up here. Okay, so that should be fine. We're getting this array here, and now we are updating the start. So we'll now say start minus equal 1, and at some point this will be less than 0, and then this while loop will terminate. You know what? Let's try this. I'm not going to use our very initial array up here. I'm going to go down here and I'm going to define this. A is equal to this. Oh, geez. Should not have copied these brackets. And now we'll type heapify A, and well, it has 5 array elements. I'm going to run this. It does not throw an error, so let's see. I'm just going to call this process. It doesn't really, or actually, let's just call this generator. Generator is equal to this. And then we're going to print next generator. Okay, next, let's type that. So here that appears to be working. So let's print that a couple of times. And now at some point it's going to throw an error because there's nothing to be done here. So let's go back up here. And I hope I coded this right. But the, okay, 52413. Okay, so what's happening here? It's sifting this down. 25413, that's the original. And then it says 52413. And then it doesn't make this very last step here. So maybe it's just not showing that. But I think the whole thing is actually working. the problem is that we are yielding before we are making the swap. So could this be the problem? I think it could be. We are yielding before we made the swap, so we are not seeing all the steps that are involved to get from here to there. So we are only seeing until we get here, but it's actually done, I believe. So we'll see that in a second when we are now coding the actual heap sort function. But I think we are on a good way. So it's a good sign to see this 52413 thing here. Okay. So I'm now gonna delete all of this. Gonna exit out of the console down here, and now we'll define the heap sort function. So here we'll just have our array, and now we're going to define n. And step one, that's building the heap structure. So here we're now going to yield from heapify. And yeah, so yield from heapify, and we're now going to use a and n, which are these two variables, a and n. And now comes step two, or let's call this phase one and phase two, I think, because step two is not roughly the same size as step one, but it's going to take a lot longer. So run selection sort, we learned about this in the past video. So run selection sort on the heap structure, okay? So this is now what's happening. We have created this heap structure. Now that there is some structure applied to this, we can really exploit this, okay? So let's set n equal to -1. And then while n is not, n is greater than 0. So with n, this wouldn't work because n, well, it's just, it's a constant. And n is the one that's actually being updated. So, yeah, I think now all that we have to do is, well, we have to swap the elements. So swap first and last element. Just a little explanation here. So we move the largest element to the end. So if you go back up here, this is what we saw. So at first we moved this 5 to the end, then we moved the 4 towards the end, not the exact end, but towards the end, right before that 5, and then came 3 and so on. And then this is the whole idea of this swapping part at this point. So we were swapping this down here, and to do that we'll just say a end, so the array element at that position of end, and then we'll take the first one, and now we'll just have them in reverse order. So now we have a end, and now we're sifting down. So sift down the new root, and then we'll just say having locked in the new last element. So that's important, okay? So end is now equal to, well, end minus equal 1, not exclamation mark. And now we're going to yield from our sift down function. And well, now we're using 0 again, but then it's only going to go until end. And I know that this was now a lot to take in, and I'm not too sure whether I coded everything correctly, but I think this should be right, this heapify part. So yeah, I guess there's only one way to figure this out. Let's take our array and let's try this. So a is equal to this, and it's yielding down, and then can I just throw in a return statement down here? Return a. I don't think that's going to work. So I think because we're now mixing yields and returns, so that's not a good idea. So I'm just going to call this the sorting process is equal to heap sort a. And now we'll just print next in process. And you know what? I'm just going to copy paste this a couple of times, and we'll see that at some point it's going to throw an error. But right before that, it now says 13245. So let's go back up to the numerical example. Can we see some resemblance here? I don't really know at which point it now returned this. 25413, that's the initial one. It now says 52413, which is this thing here. Then comes 23415, 23415, which is this. And then comes 1, 3, 2, 4, 5, which is now this. And now it throws an error. It does not show any further steps. So yeah, let's see whether this is actually going to work when using it in our animate function. Okay, so I'm going to go back into our animate function here. And now I'm going to add from heap import heap sort. And we'll add this down here as well. Heap sort, sort, and then we'll say heap sort without the comma. Go over to our main and change this to heap sort. And let's have a look at the map. Yes, this is looking good. So I think it's actually working. We are now seeing this heap structure. It goes all the way in the end. We did everything correctly. We just couldn't really peek inside other than like the first couple of steps, which is what we saw down here when I walked through these steps of the numerical example from above. The only thing that's left to do is throwing in some of the colors, okay? And it kind of bothers me that we couldn't see the example, right? So I'm gonna include this once more, and for us to be able to see the example, I think what we have to do is we have to throw in. So this is just for the example. This is not part of our actual code here, so we'll have to erase that later on. Let's just yield A in this little step here, okay? And if I run this now, I don't get an error. I might have to add some additional. What did I just do here? Okay, so it's that last one that is one too many. But now we should see all the extra steps involved. So let's go back up here. We start with creating the max heap. 25413, that's our initial unsorted array. And now it reads 52413, 52413, which is that. Then comes 53412, 53412. Okay, this is now the first three lines here. The first three returns are what's creating the max heap. And now we're sifting down in phase 2 of our heap sort algorithm. So it now says 23415, which is 23415. This now comes 43215. Okay, now we have this first sifting down part. Now comes the next one. So we are now in the next iteration, 13245. That appears to be working, 13245. Then comes 31245, which is this, and we are now almost done. So it now says 21345, 21345, and it's not showing the last bit, 21345, and that's just because of this. We're first yielding and then making the actual swap, so we are missing out on that very last step. It's still happening, it's just not shown in the details here while we're doing this. You know what? I'm just going to leave in this new line here, which is kind of nice because it shows us how our numerical example works step by step. And I don't know if this is going to work. Let's just run it like this. And yeah, this is also working. So we can just leave that in there. And let's try to add the colors, okay? So I'm going to go up here. Where's that? So now, when we are making the swap, is it here within this sift down function down here where we would like to add the colors? I think we should add some colors here. So what we'll do is we can highlight everything from start to end. I think that's a good idea because we have a start and end. So let's first add that. So what we'll do, we'll have a list of a range object, and this range object will run from start until end. Remember Python indexing, if we want the end to be included, we have to add +1. And then we could also add, well, the swap and the root maybe. So because these were the two that we are about to be swapping. Remember, we were first yielding and then we were actually making the swap. So yeah, I think this is about what we could possibly yield from here. And yeah, let's see what that looks like. I'm going to go back to the main, run this, and okay, so what's happening here is that, okay, let's slow this down. Let's bring this to the speed of 10. So we can now see that the computer is creating the heap. So it's now everything is red. It's creating the max heap structure. And now we have this massive flickering going on because now it's just in phase 2. So it's doing the selection sort, sifting down, selection sort, sifting down, and so on. And this flickering doesn't really look too nice. So, but we can turn that back off if we go back to the heap. And this is where I said this is not just for the example. I'm not going to erase this, so this might be interesting for you to see. But let's just put this into a comment. And if we run this now, I think we now have our heapify phase, our max heap phase 1 of the algorithm. And now, yeah, this is a lot better. Now comes just phase 2, and we're just highlighting where it is that we are making the swaps. And this is now a lot more pleasing to the eye. If you are a purist, you might want to have that second element also included, that second yield statement. But I think since our whole journey here is the whole point of these videos is for you to be able to visualize that. And I think in terms of visualizing heap sort, this is a better way of doing it. But if you prefer the other way, I mean, the goal here is to give you the ability to visualize it. And if you think this other visualization is better, go with that. Feel free. For everybody else, let's just leave it at that. It's going to bring that to 100. You know what? Let's just make this 500 elements and go. So we are now in phase 1 until we are all the way over there. Boom, and now comes phase 2. We're now running selection sort on this heapified structure, and you can't really see a whole lot. Of course, larger elements are to the left, so you can kind of tell that, well, there's a tree underlying that because, well, the root is greater than everything else. But other than that, it still looks kind of, it's not sorted. It's not like, perfectly sorted from largest to smallest. But there's just like a general pattern there. And because of that, heap sort is now a lot faster than regular selection sort for that matter. And yeah, now it's just a couple of seconds left until this animation will terminate. I hope you enjoyed this video. I hope you learned a lot. And yeah, see you in the next video. Until then.